Every so often in the instrument school, a student will come along with a great deal of perseverance. You're looking at a control rig that has both temperature and pressure experiments built into it. It hasn't operated effectively for around about 15 years. And John Barclay decided that he would get stuck into this and make it work. Affectionately, he calls it the machine. And John wrote all the manuals, he rewired the whole system, replaced all the tubing, and proved that all the experiments that had been designed in the United States actually do work on this system. While in the process of modernising the plant, John wrote several manuals, including an overview manual which makes the operation of the system apparent to all the students who might follow him. We're now going to listen to John tell us how he did it.
It's away.
Right, what we have here is two experiments. One is temperature control and one is level control. This one is the level control and this one is the temperature control. The level control unit and the temperature control is an add-on unit. Alright, here, temperature control unit. It has a cold water supply from the base unit here, and it's pumped in from a reservoir underneath this unit here, and it comes in here, and it comes through a fixed flow. Comes into the heater, and a variable flow controlled by the control valve. Right now we're mixing it right here. It's 60%. So what we've got here is hot and cold water being mixed together, and then warm water coming out.
And what about the level one? What's happening there?
The level one, same pump supplies through a control valve into the tank. 1 meter, calibrated for 1 meter of water.
And that relates to the set point?
The set point, yes, 50% is going to be halfway. So we've got the ruler right there, so that's half a meter. And we've got the set point. The set point is 50%. And the process value is 50%. Also, we've got a chart recorder on that is right now is we're looking at number 2. These are all the test points in the machine. This top set is for the level control. This bottom set is for the temperature control, so we can monitor the values on the chart recorder. Well, this is a bit hard to use because you have to put paper and ink into it, and it's very messy. So basically, it's obsolete. It's still connected, so you can still see the values, and you select them with. We've got 3 pens, which can be monitor all the test points by these switches. But it's pretty well obsolete these days. So right over here we've got a computerized version of the chart recorder.
And you call that a data logger?
The data logger. Yeah.
Okay, and you put that on yourself?
Yes, so this is a very inexpensive setup here. This device costs $50 from America. This is an obsolete Windows XP computer, which they're practically giving them away these days. And it's got 8 channels, so there's more than 8 channels to monitor here. So I've got a switch box in here to select between the temperature and the level experiment. This is a little recirculation pump to stir up the water in the hot water tank, so you get the whole tank full of hot water. There's a little light on the side here to indicate when the recirculate in the tank. You can't go backwards back into the water pump because the pressure, the flow regulator, I beg your pardon, won't allow it. It'll only allow the flow to enter the tank, not to go backwards out of the tank.
So it's like a non-return valve.
Non-return valve.
Now you supplied a bigger transformer here to run it?
This it's just a 110 volt transformer. This is an American machine, so all these controllers and chart recorders run off 110 volts. All the I to P and P to I converters, they also run on 110 volts. So this is just a replacement transformer for the broken one that was, or a missing one that was used to be here. Just put another transformer in there. Yes.
The documentation, John, for the shop.
These are the original books right here. These three books here. This is the plans and all the information on the valves and controllers and plans for the wiring diagrams for the machine. And these two books here are for the experiments. You've got the level experiments here. What they actually have here is multiple copies of the same experiments. So that's the level experiments. In the right here, you've got the temperature experiments. Same thing, and multiple copies of the same experiments. So, and these experiments are fairly opaque. They don't explain what they're doing, and there's no overall overview of what the machine is, how the machine is arranged. So I just took the experiments and put them all together, just one single copy of each. And also I wrote this little introduction here, which explains, it gives you an overview of what how the machine's arranged. Okay, so that's my little introduction here, and then I just put just one copy of the experiments and just rearranged it so you can find stuff. This is the level experiments setup, level experiments, then the temperature setup, and the temperature experiments, and then in the back here is the tuning for a gain controller and a proportional controller, same thing. But these little instructions on reaction curve.
Tabs in your manual for?
They're just dividing up the, well, as I said, setup, and the different sections in the setup, and then the experiments, and these are all the different experiments. Install valve experiment with proportional, derivative action, gain and stability, lags and stability, tuning. What's this one? Startup response, load disturbance, valve position. Cascade tuning. Yes, each of these controllers have got actually two loops in them. So they
So they've got a display plus a hidden one.
they have you can still see it actually. They've got process set points valve and these X and Y. So there's a couple of extra points they can monitor inside the controller, so you can see what's going on with the second loop.
Now how long does it take before you can actually start the experiments on the unit, Ron?
Level experiment, pretty well straight away. Just turn the machine on and you're right to go. Well, there's some fiddling around to do with these valves to set it up according to the book, but basically you're right to go straight away. And the temperature experiment, that takes about an hour for the tank, water tank to heat up, and also for the cooler to cool the reservoir here. So yeah, about an hour.
So, as I understand it then, we're taking the hot water into the level if we want to, but we need to cool it before we send it back to the hot water tank. In other words, we're not recirculating hot
Otherwise,
water.
otherwise you're going to end up with a whole lot of hot water. You need to have a cool water supply and a hot water supply to get a warm water supply.
So we've got 21.2 degrees here now.
Yes, because there is actually hot water flowing into the tank now, and it's
And the cooler's cooling it down.
Yes, the cooler's cooling it down. Actually, there's a 10 degrees coming out of the cooler right now, so it's having trouble keeping up with the hot water being put into the tank. But it's still low enough to control the temperature. As you can see, I've got 60. It's not having any trouble controlling the temperature over here. It's still within. There's still enough cold water to allow it to control the temperature.
And that's in percentages?
That's percentage, yes.
Okay. Now, we can change, I believe, from a small tank to a large tank.
Yes, this has got a rather cunning device in it. It's got two tanks, one inside of the other. So right now we're on the small volume tank, this one down here, and right now it's locked off. No water can enter this tank, no water can escape from this tank. Right now, we've got a small volume tank. If we, there's a switch here which lets air into the middle tank, the high volume tank, and as soon as we switch it, you'll see this level come up to meet the two tanks will equalise.
So you switched over to the large tank,
Yeah.
and it's starting to rise.
Yes.
Because it has a larger capacity, it'll take longer to do.
Yeah. It'll get there.
All right, John, I think that's quite a good effort in making this work, and it's a credit to you.
And while we've been doing this, the file's being recorded. We've only, even though we were recording 8 channels right here, so we're recording all the. That's right. Oh, we're only recording the temperature experiment right now, but.
Well, that's all right.
Not so. The data logger. It's connected to the computer via a USB cable. And this is the incoming signals. These are the same signals that the chart recorder can monitor, except we've got 8 channels.
So what's it recording? 1 to 5 volts or 0 to 5 volts? On a
1 to 5 volts.
1 to 5
and then also, and they've got engineering percentages over engineering units over here. So I change it to 0 to 100%.
Yeah.
So that represented by 1 to 5 volts.
Now the computer you're telling me is a Toshiba or Samsung? HP.
Well, this is effectively an obsolete computer, which means it's practically being given away for free. The resale value of this is almost nothing, but it's more than adequate. It's much more than adequate for acting as a data logger. It does everything you want and more.
And the software that's running that
it comes with the
it comes with the
box, with the data logger, yes.
And that costs what? Less than $100?
Well, $50.
$50?
Yes.
And from the United States?
Yes.
Okay.
Well, this is their to try and get you involved with their products. So they sell a low cost version of their high-end product, so you can
make it work.
Get involved with their products.
So all up, what did it cost you? I mean, basically, did it cost what, over hundreds of dollars, or?
It cost, let me see, $20, $10 for the little temperature things, probably $500, I would say.
About $500 all up.
Maybe. Yeah.
For a complete experiment.
For the pump as well.
Yeah.
and the computer and the data logger, or the switch box was one of the hardest things to fix in this machine was actually the hot water tank, which it's at first glance it seems simple, just a hot water tank, but there's some very strange things going on in there. There are water vapor bubbles which collect at the top of the tank that upset the measurement of the temperature. Initially I had the temperature sensor at the top of the tank and it didn't work properly. And eventually I moved it down to the middle of the tank because of this strange effect with the water vapor in the top of the tank. And also the water vapor goes through the experiment and causes noise in the RTD temperature sensor. You can actually see this on the data logger, and it makes enough noise so you can't put any derivatives actually.
So the noise is really the fluctuations of temperature. Bubbles.
Yes, bubbles passing the RTD.
Passing the RTD sensor head.
Yeah.
So,
right now it's not heating but the lights on.
no, that's okay. I can understand that. I got that. So put your finger on where the sensor is currently.
It's underneath the original bimetal. Yes, in the middle. Actually, you can see the bubbles. You can actually see the bubbles going. Oh, there they are. See, you can actually see the bubbles travelling around in the tube here. The water vapor bubbles. You can see. Well, there goes one.
There goes that,
Yes.
I'll keep it going for a while. I don't know whether I've got enough light on that.
And finally, John has the recirculating water pump running really well, and the cooler that you see there, bringing the temperature down. And it's taken an hour or so to do that as we made this documentary. And you can see its set point is 10 degrees and he's almost there at 11. One can't really praise John enough for the amount of effort he put into this project, and he's resurrected a 15-year-old non-goer and turned it into a really good control system.